Hey, good morning, everybody. So we're finally set up. Glad to be here. I'm Jan Camenisch. I'm CTO at the Definity Foundation. Yeah, I just realized it's almost exactly 30 years since I've been in crypto. I started working on like eCash, cryptographic protocol, zero knowledge proofs, like back in '93. When I walked around here yesterday and the day before that, got really excited about like all the stuff that is going on here, like all the zero knowledge things and so on. And so I'm happy to talk to you today about World Computer and like, another topic I find very excited, and in particular how like Ethereum and the Internet Computer together can realize the World Computer already today. So what I mean, we have like Ethereum with like all its smart contracts, we have Bitcoin as a cryptocurrency, and then we have the Internet Computer where smart contracts can trustlessly communicate with other chains. They can serve web into users' browsers, and user, because of the reverse gas model, can just connect with their browsers only to any smart contract on the Internet Computer. And if the smart contract becomes very popular with users, they can scale up just seamlessly without any hiccup. So in other words, what I'm talking about is the ICP, Ethereum, and Bitcoin together really form a crypto crowd, and we can today build almost everything just with smart contracts. So for instance, we have a full social network, or many full social networks actually already on the Internet Computer that are 100% on-chain. There's no cloud components for them whatsoever. So we can have really like a blockchain singularity where all of the world's software is written with smart contracts and is run off blockchains. So let's see how we can realize the World Computer vision back from 2014. So if you look at a ton of applications today that say, okay, we have built a Web3 application on a blockchain, typically the picture you see is something like the following here, where you have some component of the service hosted on some blockchain, some tokens, snippets of code, snippets of data, but actually most of the application is hosted on some cloud service. Like almost all the logic, almost all the user interaction is hosted on a cloud service. And the cloud service is of course paid by some developer, by some other parties, a ton of registration going on there. And so when users interact with that service, they're actually interacting with the Amazon cloud. And so as a user you would think like a Web3 service means, hey, a Web3 service is like a DAO that's controlled by the users, that's owned by the users, and so on and so forth. But that's actually not possible here because we have this decentralized component right in the middle here. And that decentralized component has a ton of issues because it can get hacked, there's regulators, there's other vested interests, it can have censorship. And we see that all over again. So we read about bridges getting hacked like every other day. We remember how Parler got blocked by Amazon, how MetaMask was banned from the Google Play Store for a while, or maybe Badger DAO that had issues with Cloudflare. And that's where ICP comes in. So actually we can replace all of what people build today on Amazon Cloud or other cloud providers. We can put that on ICP, run it fully from a blockchain. So really like other blockchains together with ICP, we can build a World Computer that users can directly interact with from their browsers. And here's a few examples that are built on the Internet Computer blockchain. And I invite you to go to this URL. It has a ton of other examples. So we already have like a Uniswap front end on the Internet Computer. So now you have Uniswap. You can interact with Uniswap fully, only with blockchain technology. We have a few social networks as well here. I'm not sure how well you see the pictures here. We have like a fully on-chain DEX also running today on the Internet Computer. So let's see how we can do that. Let me explain you what the Internet Computer does. Let's do a crash course on the Internet Computer Protocol. So the Internet Computer Protocol does approve node machines that are provided by independent parties, and then it connects them together into subnets. And these nodes are really server-grade machines hosted in professionally run data center, in independent data centers, and operated professionally. Currently, there is like more than 1,200 machines on the Internet Computer Protocol from about 79 independent providers. And we have like weekly proposals to the protocol with like new node providers who want to join the network. As I was saying, so the Internet Computer Protocol then groups these node machines into blockchain subnets. So each of these subnets are independent blockchains by themselves. They have different sizes, they run in different geographies, and so developers can pick on which subnets they want to host their smart contracts depending on their security, cost requirements, or their jurisdiction requirements. These blockchain then replicate and run the smart contracts, the ICP smart contracts or canisters as they're called on the Internet Computer. These smart contracts can be programmed in almost any language that compiles to WASM. So for instance, popular languages are Rust or TypeScript, or also Motoko, the native language of the Internet Computer. And the subnets then route traffics between these smart contracts from one subnet to the other subnet. So to a smart contract, the whole thing really looks like a single virtual computer that can scale capacity as smart contracts grows, as usage grows, but just adding more subnets and more subnets and more subnets. Also for users, it looks like a single computer. A user can just interact with ICP smart contracts just with any browsers. Every smart contract has a URL, and by just typing that URL into your browsers, you're talking to the Internet Computer blockchain already. So users don't need to install any plugins like MetaMask or whatsoever. They don't need to have any tokens and so on and so forth. There's no hurdle for users to use that. And in fact, really can implement almost anything, any applications on with ICP smart contracts. Again, we have chat services. You can do games, social media, DeFi, GameFi, all of that. Again, here's the URL. You can go and see what's already being built. And of course, I invite you all to build much more on the Internet Computer Protocol. One feature that is also unique to the Internet Computer Protocol is that it is governed by an on-chain DAO. So the on-chain DAO is called the network nervous system, and it's really just like another smart contract that users interact with from their browsers or from their ledger devices and so on and so forth. So users can get ICP tokens and stake them, and then they get so-called neurons. With these neurons, they can vote on proposals made to the network nervous system. The proposals include like application of new node providers, new node machines, forming the node machines into the different subnets, or actually upgrading the replica software on all the nodes. And all these proposals, whenever they get accepted, get executed autonomously. There's no human interaction whatsoever. So the only human interaction is voting and submitting these proposals. And in fact, since launch back in May 21, the network nervous system has voted and adopted more than 110,000 proposals. Okay, so let's now we know how the Internet Computer works on a high level. So let's look about what capabilities it offers to ICP smart contracts. First of all, which is I guess an exciting topic because there's some action on that happening like on Saturday morning. So one of the game changers is ICP has a DAO factory built in. So as a developer, if you have some smart contract, some application done with smart contracts, you can submit a proposal to the Internet Computer Protocol to create a DAO for that smart contract. So when the proposal gets accepted, the protocol will actually autonomously generate tokens, organize a decentralization sale, and then anyone who buys these newly created tokens becomes then a participant in the DAO for this application. And the DAO fully controls that application. So again, just like the Internet Computer itself, you can submit them proposals to change the application through that DAO. And like that, also developers can raise funds from anywhere in the earth, on Earth, to make a decentralization sale, and the proceeds from the decentralization sale go into the treasury of that DAO. And just on Saturday morning, we had the open chat, which is like a messaging protocol, a messaging application on the Internet Computer. they had just done this DAO creation and raised about $5.5 million US dollars in that decentralization sale. So they now have a nice treasury to build on their OpenChat protocol even further. Again, I invite you to go and check out OpenChat, maybe even buy some chat token on the secondary market and become a participant in the OpenChat DAO. Another property that the Internet Computer has, we already talked about that users can just interact with the Internet Computer with their browsers. Now, of course, that interaction needs to be secured. So the way for users to authenticate their messages to the Internet Computer is via WebAuthn. So that means your computer, your device creates like a public key secret key pair that is used to sign messages to the Internet Computer, and you can just authorize them with your fingerprint on your device. Likewise, communication from smart contracts on the Internet Computer to the user devices is secured with what we call chain key cryptography. So that is like a bunch of protocols, threshold cryptography and so on and so forth. But what it really matters is that the Internet Computer has like a single public key, and that public key is all you need in order to authenticate messages originating from smart contracts, results computed by smart contract from the Internet Computer. Under the hood, how this works is using threshold cryptography and secret sharing, the secret key belonging to that single public key of the Internet Computer is shared amongst the nodes of the Internet Computer. And then whenever results like smart contracts are computed, like each of these replicas run these smart contracts, compute the result, sign the results with their respective secret share, and then these, through consensus and so on and so forth, these signature shares are combined into the signature that is then sent to the user. Another cool feature is that smart contracts on the Internet Computer can actually communicate with the outside world. They can make HTTP requests to like any HTTP endpoint out there in the world. And this is a very cool feature because now with this you can implement oracles with ICP smart contract directly on the Internet Computer. And actually such an oracle already exists. So there's like a smart contract that offers any other smart contracts the price between any popular pair of tokens and also fiat to tokens. Of course, also smart contracts using this can send email, they can interact with other chains, just like a ton of application. I guess imagination is the limit here. How this works under the hood, again, the Internet Computer Protocol provides an API to smart contracts that they can call with the address they want to query. That then goes down to each of the replicas of the subnet that run the smart contract, and they make the call out individually and then get the result back. Of course, that result might be different. There might be different whatever timestamps, but also the result itself might be different. And in order to remove the timestamps, the replicas apply like a filter provided by the smart contract to sort of normalize these responses, and then pipe the responses through consensus. And if consensus is reached, the result is passed back up to the smart contract. So that's how smart contracts can interact without any third-party involvement with the rest of the world. Another really cool feature is that smart contracts can have their own ECDSA public keys. So they can actually themselves sign messages, not only when they send a message to users, those messages are signed by the Internet Computer, but they can also themselves sign messages with ECDSA signatures. So in other words, that allows them to own crypto themselves. They can sign transactions to the Ethereum network, to like any other crypto network like that. Under the hood, again, how this works with chain key cryptography, like a combination of threshold crypto, multi-party computation, and consensus protocol. And again, the secret key here is shared amongst all the nodes of the network, and then they sign the message the smart contracts asks to be signed with these individual shares. Then they get combined again through consensus, and then the smart contract can sign or send that signed transactions to anywhere it wants, like with HTTP out requests. Or actually, so with HTTP out requests to any other network. So the smart contract can own Bitcoin, can own Ethereum, they can own USD coins. Now, in order to make this even easier, the Internet Computer Protocol is integrated with the Bitcoin network. So that means on some of the subnets, each of the replicas run like a Bitcoin adapter. Those adapters pull in the blocks from the Bitcoin network, run them through consensus, compute the UTXO set to that, and make that UTXO set available to smart contracts on the internet computer. So with that, it's very easy for smart contracts to receive Bitcoin and to send Bitcoin. It's just all integrated, no bridges or any other third parties needed for that. And of course, one nice application for that is already built. It's called CKBTC. So that's like a specific smart contract to which you can send Bitcoin and then receive like a handle to CKBTC, like another token really. And that ledger smart contract then allows you to transact Bitcoin very quickly on the intercomputer network. So with that, actually, and users with their smartphones being able to directly interact with that smart contract again, users can transact Bitcoin in a matter of seconds, just with their smartphones. Also, on the OpenChat protocol I just mentioned, there also users can send each other Bitcoin or ICP, like other crypto token with that technology. And going back to the word computer vision, we are currently also integrating Ethereum with the internet computer in very much the same way. So the goal here is that on some of the subnets, every node also runs an Ethereum node, so interacts, is a part of the Ethereum network. And then with that, ICP smart contracts can directly interact, query, and transact with the Ethereum network. And likewise, Ethereum smart contracts can also reach out and interact with ICP smart contracts. So let's see about the roadmap here. It's really like 3 phases here. The first phase is already done, as smart contracts on the internet computer can have their own ECDSA public key, so that means they can own ETH. And with the HTTP out calls, they can already send Ethereum transactions to the Ethereum network. Now, of course, that is not a very seamless integration, so we want to make that better. So the next phase, and that's like in the works now, and hopefully finished in a few weeks, is or actually the Dfinity Foundation together with some members of the community is working on like a system interface where smart contracts can then talk to the Ethereum network. And in the first phase, those calls will then just be routed through Infura, Alchemy, and QuickNotes, like other providers. And so like that, the integration with Ethereum can start. And then later on, we're replacing those calls with just direct calls to Ethereum nodes on the internet computer. Another exciting project that's already going on, some community members like InfinitySwap, they're building an EVM engine also as an ICP smart contract on the internet computer, so you could even run Ethereum smart contracts directly on the internet computer as well. So that's how that will take a bit longer to finish, hopefully in a few months, but definitely should be done this year as well. Okay, so that's how we can build the world computer. I've talked a lot about capabilities for ICP smart contracts. There's a ton of more. I just picked 6 more here, because otherwise I would be standing here and talking all day. Another cool thing is, I mean, we already said that every smart contract on ICP has their own URL, but they also can have their own custom domain name. So for instance, internetcomputer.org is just a domain name for a smart contract that serves the internet computer website. OC.app is the URL for the OpenChat. Discover.one is the URL for the Discover network, and so on and so forth. There's a ton of those already. And actually, you can, if you forgot about the URL, you just can go on Google and search for those smart contracts as well, because the internet computer offers search engine optimization, and that makes all of them searchable on Google. ICP offers cheap storage to smart contracts. So first of all, every smart contract has like 48 gigabytes right now. It's going to be grow of persistent storage available. You can have 4 gigabytes of stack or heap. So imagine no other blockchain can offer that kind of environment for a smart contract. So you're programming really as you would program for a web for like a cloud service here. And storing is cheap as well. So like 1 gigabyte costs just like $5 per year. And those costs are fixed and low. They're not depending on the price of the ICP token or any other token. It only can go down as the protocol becomes more efficient. It also offers high throughput. So like for every subnet can handle something like 975 update calls per second, and even more query calls. That of course depends on nodes because the queries are just served by the single nodes. But on a small 30-node subnet, you can handle like 65,000 queries a second. If you have more nodes, of course, that goes up. And we have like 40 and 60 node subnets as well. It's also blazing fast. Transactions are finalized between 1 and 2 seconds, and the query call is just served in like under 200 milliseconds. So really what I mean here is we can realize the world computer already today. You can build smart contracts on the intercomputer, interact with smart contracts on Ethereum, have them own Bitcoin. So there we go. We can build the world computer. Yeah, and come and build, interact with also with the Ethereum Foundation doing that. We're glad to talk to you, to help you build, to explain you the intercomputer and so on and so forth. And actually we probably have, or we for sure have the largest team of cryptographers in tech at all, not only the blockchain industry, and we are also the largest employer of senior Google engineers. So the Ethereum Foundation was founded back in 2016 to continue really working on this vision of the world computer that was started in 2015. So we're a Swiss foundation based in Zurich, but we also have offices in San Francisco. So yeah, come and start Let's Coding, come and see us at the booth over there, and happy to talk with you all day about ICP. Thank you.